Okay, so what we're going to do look here is now we're going to look at free fall. And free fall is a special one-dimensional motion where the acceleration will always be the same. It's always going to be a given value. Um, don't let the word fall kind of deceive you. And we'll talk about that here in a little bit, what that really means. It can be deceiving. But what you have to understand is that free fall is any object that will fall freely under only the influence of gravity. So we're not going to account for this is where we kind of talk about the physics world. So you can see all the word falls in the phrase. It also applies to objects when you throw them upwards within a velocity. Now, to simplify things, again, we're going to only under the influence of gravity. To simplify it, we're just going to say that the that we're going to ignore air resistance. Okay, so there are ways we can do that in a lab setting by using the shapes of objects and so forth. But when you do calculations, you're just going to make this assumption that air resistance is negligible, and this way it just becomes easier to solve the problem. If you accounted for air resistance, then it would have to be more of a force problem than a motion problem. So all objects are going to have the same acceleration, and that is known as the acceleration due to gravity. And this is a value that is specific to, let's say, the planet that you're on. Okay, it's given the special symbol of lowercase g. Now, here on Earth, and I'm going to put the negative sign because we're always making this assumption that it's going to be heading down. It not making an assumption, it always is towards the center of the Earth. On the AP test, if they don't tell you to use a specific number, then you can just simply say that it's negative 10 meters per second squared. I would say that negative 10 is a lot easier to work with than negative 9.8 or 9.81. You'll have to look at the specific problem as to what they say, because if you use 10 and they want 9.8 or 9.81, your numbers are going to be wrong, which means you're not going to get those points in the end. So this next chart kind of just gives you an idea of that the acceleration is always negative, okay? Regardless of what is happening, your acceleration due to gravity, this g value, is always down. It's always heading down towards the center of the Earth, okay? So and the arrows outside these charts indicate where positive is. So for example, this first box here says going down. This would be as if an object was falling down. So it means our velocity is down, our displacement is down, but remember our acceleration is always down. But because we define the positive to be upward, the velocity would have a negative sign, the displacement would have a negative sign, and the acceleration would also have a negative sign. Okay. Now, if you go what happens is in this scenario, we threw the object up first. So the velocity would be up, the displacement would be up, but always the acceleration is down. Okay, so that puts the velocity as a positive, displacement as a positive, but the acceleration is a negative. Okay. Now, to make problems easier, you may want to flip the positive. Now, physics does that, and it's very common to change the axis around. Math classes don't like to do that because positive has to be up, positive has to be to the right. But in physics, we change it to be easier for us. So we'll often change the positive direction to be down. It could be down and left. Okay. So here we go. So if we're heading down in this scenario, right? So all of our velocity, our displacement, and our acceleration are down. But because we define positive to be down, they're all going to be positive. Okay. And so now if we go where we throw it up, so our first two would be our velocity and our displacement would be positive, or excuse me, we'll be pointing up. Our acceleration would be down. Okay, but because we defined in this box the positive is down, our displacement and our velocity would be up, or excuse me, would be negative, but our acceleration would be positive because it points in the same direction as our axis. Okay, and so one key point to note is that if an object is traveling upwards, key point is if the object is traveling upwards is key point meaning the key location. Sorry, I confused myself on how. So a key location if we're throwing an object up, right? So if I just take an object and I throw it upwards, it's going to take a path that looks something like this. This is the key location that we're talking about, and that's what we call the maximum height. Okay, so this is how high the object will rise before it has to stop and it comes down. So what happens is at this point the object has stopped moving upwards, right? And it starts to move back down, right? So up here, its final velocity would be 0, even though its initial velocity would not be 0. Okay, but at the top, at that key point, the maximum height, it's going to be the velocity be 0. Okay, so this is the point of symmetry. Okay, so this type of motion that we speak of is symmetrical. So there's a saying in physics: the time to rise equals the time to fall. Okay, so you can see here, if it takes 2 seconds to go up to the maximum height, it's going to take 2 seconds to come back down to its original position. And one thing to note also, if I have a positive velocity, right, upwards, at that same height, I will have a negative velocity with the same magnitude. So these two numbers would be the same. The only thing that would be different are those signs. Okay. Now, objects can experience one of 3 free falls. Again, don't let this word falls throw you off. Okay. That just means that there's no influence of gravity. All right. So what are the 3 things you can do? An object can just be simply dropped, which tells us the initial velocity is 0. Right, so it's like if I held my hand out, had an object in my hand, and I just let it go. Okay, it can be thrown upwards, which means my initial velocity would be greater than 0, which means it is a positive value. Okay, especially we always these are just scenarios where you want to do the initial velocity or the positive direction pointed up, and then you can throw it down. Right, so if you get mad at something, right, and you have something in your hands, you're going to throw it down onto the ground, which tells us that our initial velocity is less than 0, which means it's going to be negative. Okay. Now, remember when we talked about those equations and we define or we write down our given values, when you have to determine which of those 3 scenarios are you doing, and so that you can make sure you're plugging in the right sign. Okay. And so now we have an object. The difference too is our VS will always be negative, okay? Because the object, especially if it talks about striking the ground, VF will always be a non-negative 0 number, okay, or a non-negative non-zero number, okay? Because it's striking the ground down, okay? So first example, an object is launched upward and reaches its maximum height in 10 seconds. What is its initial launch speed, right? So if we kind of write down our information, right? So we're looking for they tell us about this maximum height, but they don't ask for it, okay? We're looking for our initial velocity at the maximum height. Remember, our final velocity is 0. Our acceleration is always either -10 or -9.81, and here I'll just use -10. And then our time is given to us as 10 seconds. So if we remember, those kinematics equations apply for free fall. And so we're going to use that first equation that we spoke of, that v equals v0 plus at. So final velocity equals initial velocity plus acceleration times time. And we're just going to solve this for v0. Right, so at the maximum height, this is 0, and so I can just do the algebra. It ends up just being negative at. Right, so negative acceleration times time. And so what is my acceleration? Or excuse me, what is my initial velocity? So we're going to plug in a is -10 or -9.81. All right, whichever one you want to use. And it took 10 seconds to do this, and you'll note that negative times negative is a positive. That's right. So our initial velocity is 100 meters per second. Okay. Another way you could do this kind of pictorially, if you were to do like a motion diagram, you would have, and each dot in the motion diagram represents a second of travel. So you would have 10 dots going up and 10 dots coming back down if you're looking for the second half of the problem. Now, the next example, so as an object is dropped, right? So here's our key. This is a keyword right here, the word dropped. So it's dropped from a building of 100 meters. How fast is it moving as it strikes the ground? Okay, so if we write down our information, our displacement is negative 100 meters, right? Because if this is my scenario, right, I'm hitting below, this is where y equals 0, right? So our initial is 0. My final is below that point. So it's going to be a negative 100 meters. And then initial velocity is 0 meters per second because it is just dropped. Our final velocity is what we're looking for. Our acceleration, again, we're going to use negative 10. Okay, so negative 10 meters per second squared. And time is kind of our value that we don't care about at this point in time for this scenario, for this problem. Okay, so what we're going to do is, since we don't have time, there's only one equation that we have that doesn't have time in it, and it's that v squared equals VL squared plus 2a delta y, right? And so this is 0. And again, this equation, you have to take the square root. But one thing to note, remember when you take the square root, it's actually plus or minus, right? And so we know that because we're heading down. I jumped up all of a sudden. So we know since we're heading down that we're going to disregard the positive, and our answer is going to be negative, right? Because our path will take us in the down direction, which is the negative. Okay, so now we just plug in our numbers. So we're going to do negative square root of 2 times negative 10 times negative 100. Okay. And so if I do that, hold on, I'll grab my calculator wherever it went. Over here. Okay, so we have the square root of 2 times 10 times 100. And it's going to give us a final velocity of negative 44.7 meters per second. Okay, so that's how fast it would be striking the ground. Sometimes students will want to say that this is just simply 0, but you can't say that because remember, we're talking about the instant just before